All right, good afternoon, everyone. We appreciate that you coming to join us. And so for those of you that don't know me, my name is Karen Rath. I'm the Chief Engineer at AFRL. And so we set this up as a combined elevation series as well as Chief Engineers Lunch and Learn for all the laboratory folks in order to come out. We've been doing a lot of work with SUNY Poly over the course of the past decades, certainly. But in the recent couple of months, there was an announcement last year that SUNY Poly was going to be completely reorganizing how they were functioning and working. So we've been really excited to work with that team on what the future has to offer, how we as a laboratory are going to contribute and be part of that, what we can bring to the table to help with that. So one of the things that we wanted to do was to invite some of the SUNY Poly team here to talk to all of you about what's going on, what they hope for their future, what opportunities are opening up with this reorganization, and what you can expect and listen for out of this community. So I'm not gonna stop talking because I have instructions. If there's an emergency, you are to exit that way and go down the stairs that you came in the front, and everyone starts in the parking lot. Also, this is being recorded, so it's going to be available on the Innovare YouTube site for people to go back and watch after the fact and refer to. And so, one, keep that in mind, and two, if you have any questions, it's really important that you come up to the microphone and ask them so the recording can catch that. And so it's going to make a whole lot more sense for anyone listening to it if they know the question whenever Mike answers it. So with that, I am going to turn it over to Dr. Mike Carpenter. He's the interim dean at SUNY Poly. Thank you so much for taking the time to come out, as well as the rest of your team to talk. And I'll turn it over to you to introduce the rest of your team.
Great, thanks, Karen. And I only have a couple of slides that were just for me, and I'm actually subbing for two of the faculty members. But who we have here today is Professor Bill Durgan from Mechanical Engineering. We've got Professor Arjun Sin from Electrical and Computer Engineering. We've got Professor Ulian Girasau from Electrical Engineering Technologies, and Professor Mike Rial from Computer Science. We're missing Professor Hisham Khalidi from Cybersecurity. I'll be subbing for him, and I'll try to do my best with his slides, but they're doing some really cool stuff, and I'll try to reassure that. And then Professor Joyce Shen from Mechanical Engineering Technologies is not able to join us either. But thrilled to be here today, and looking to grow more partnerships with the lab, and hopefully we'll have a good presentation for you today to hit our highlights of what we're up to and where we're looking to grow. So in terms of just a brief summary of the College of Engineering, and that's all I'll be talking about, we actually have three other colleges at the Utica campus. That's Arts and Science, Health Sciences, and the College of Business. But within the College of Engineering, we have 42 full-time faculty members. Our fall 22 enrollment was 973 undergrads and 171 master's students. We don't currently have a PhD program here at the Utica campus, but it is something we're keeping our eye on for longer-term plans. We've got 4 departments: engineering, engineering tech, computer science, and network and computer security. And then we've got a laundry list of undergraduate degrees, and I'm not going to read through all of those, but it's the classic mix of engineering and engineering tech, along with the computer science bachelor's and bachelor's master's, as well as the cybersecurity degree. And these are all 4-year degrees, and the master's, we have the accelerated master's that the students can finish in 5, or we can accept master's students, and just it's the classic 2-year program. We do have a master's degree in systems engineering, but currently that's dormant, mainly because we don't have yet enough faculty to teach that. But it's something we are looking to mount. And if there's any folks here who have an interest in teaching, I'd love to hear from you. Please talk to me or any one of these folks here. We're always looking for adjuncts in any one of these programs, whether it's the undergraduate degree or the graduate degrees. We're also currently working through approvals for the master's degree in mechanical engineering and civil engineering, and we're expecting, if that goes smoothly, optimistically fall 24, but more likely spring 25 for that. And we'll be putting the proposals together for the master's degree in electrical and computer engineering in the near future as well. We're currently seeking to fill 7 faculty positions for fall 23, so we're actively growing our faculty numbers. We had a similar number of searches open last year, and we yielded 4 new faculty members. In the last year and a half, we've received nearly $1 million in NSF funding. And that's important to note because the Utica campus has only emphasized research in a more focused fashion over the last 6 or 7 years. So it is a turnaround for us to bring that online, but all of our faculty here are working very actively to grow that aspect of our portfolio. And that's highlighted by the number of publications and presentations we had in the last academic year. Roughly 80 publications and 80 presentations from regional and national and international conferences. So we've got a really active faculty body, and we've been pretty successful with acquiring funding for infrastructure as well. We currently have $4.6 million for equipment across all of the programs within engineering, and we're just starting a $20 million capital campaign for renovations both in Donovan Hall and Kinsella Hall. And our new officer in charge, Andy Russell, if you haven't met him yet, he's terrific. He's doing a great job advocating for us for this coming budget year, and we've got a lot of big asks that are pending within SUNY and the New York State. And fingers crossed we can have some nice announcements in the next month or 2. So with our presentation here today, you're going to see a lot of information, and there's a lot of details we can't go over at all. But we're looking for a lot of feedback, a lot of conversation, and discussions on how we can collaborate more. I see opportunities for courtesy faculty appointments. This would just be, you do everything but teach, and you can help in all kinds of different ways. We're always looking for adjunct faculty. They are paid. The courtesy faculty appointments are voluntary. We've got a lot of students, real high-quality students, and we'd love to send more students here to be interns. I hear nothing but great stories about what the experiences that our students have here. And we have capstone projects. So the senior capstone projects, if you're interested in mentoring any of those, again, reach out to me, reach out to the faculty. Those are great opportunities. And then, of course, research collaborations. And you're going to see all kinds of great work that we're doing, and love to have discussions with you on how to grow that. So with that, I'm going to step aside and hand it over to Professor Sin.
Thank you very much, Dr. Carpenter. Hi, everyone. I'm Arjun Singh, here to present to you what's going on at SUNY Poly in the Electrical and Computer Engineering Department and where we are hoping to go. So, of course, to run the department, we need to have faculty people. We have 4 full-time faculty. That's Dr. Tim Bush, Dr. Michael Medley, Dr. Dan Benincasa, and myself. A few of those names might be familiar to you guys. We also have 4 adjunct professors. And we have strength in electronics, nanophotonics, communications, and digital logic when we partner in with our EET side as well. And it's a good time to be in ECE because it turns out ECE experiences continuous growth, whether we're talking about communications and how much Verizon is spending, or we talk about power systems, or we talk about computers. Turns out people like electricity and computers, and we've just got a $100 billion investment in the local region by Clay in the semiconductor field. If you look at our student success, we've demonstrated a lot of success in terms of the capstone projects. We've got automatic golf caddies that was done last year. We've got projects in terms of parking garage deployments that was also done last year. I'm talking about last year because I joined SUNY Poly last year. We've also had fantastic work from prior. We're also doing new things with the IEEE club projects. And in fact, one of the projects that students are working on right now, these are freshman year students doing high quality simulations on electromagnetic software, computer utilization. And the goal is that they're going to build an antenna that's going to be working at terahertz frequencies that will be deployed in an actual CubeSat where we have partnership with Northeastern University to be able to facilitate that. And we also have student undergraduate research projects underway. One of the ones which I'm working on right now and which has got quite a lot of interest for this summer is the development of a 6G testbed at SUNY Poly, built with millimeter wave arrays as well as intelligent reflecting surfaces that are truly intelligent. And the idea is to be able to provide a one-of-a-kind testbed that doesn't exist anywhere else, and it's modeled on the test bed that I used to work with during my PhD at Northeastern University, and a similar kind of test bed that actually exists at Innovare Advancement Center as well. Well, we also have quite a lot of research thrusts at SUNY Poly. First and foremost, it's in my domain, which is terahertz communications and wavefront engineering. And really what I've been looking at is the near field domain, because that becomes more and more important in the terahertz channel. And some of the key concepts are essentially about smart beamforming, doing more than just beamforming, really shaping those beams to do whatever we can, going to new type of wave propagation and sending information not through just modulations, but also through the actual beam itself, or orbital angular momentum. We also have, with conjunction with our folks at CNSC Albany, neuromorphic computing, and the goal is to basically show that memristors can work in a similar kind of manner and outperform our traditional FPGAs. We're also doing a lot of work in terms of student development on next generation communications, mostly related to software-defined radios, cross-layer communications, and all of these have applications in 5G, 6G, quote-unquote 7G, or let's say next G radio. And right now I'm working with Ada and Pluto. We had a very successful SDR class last year. We're still running it this year. The goal is to utilize some of that new testbed equipment and integrate it so that we also start teaching students about arrays, beamforming, and so on at a high level, of course, because we're still undergraduate, but enough so that they can get their beaks wet, so to speak. And the work that we're doing at SUNY Poly also faces a lot of alignment with the work I saw is going on at AFRL. And I kind of wanted to highlight that. So whether we talk about our terahertz communications, and that we talk about wavefront engineering, IRSs, directional antennas, beam shaping, that actually has a lot of advantages when we talk about 5G, 6G radio networks, whether we talk about spectrum sharing, whether we talk about the overall field of terahertz communication networks. We also have neuromorphic computing, which of course has direct applications with advanced computing architecture work that's going on at AFRL. We also have student development and research work going on in software-defined radios that also faces a lot of similarity with AFRL work. And we're also doing our own part in next-gen radio networking, which of course is a big portion. And I just want to kind of highlight a sort of planned work which would have direct collaboration opportunities, and that's to do with joint waveform and wavefront engineering for terahertz communications. So we've already done some prior work in this, showing that regular conventional beamforming, the way most systems work right now, is not the best way to get to 6G and 7G in terahertz. We've also shown that these new beams can actually provide you advantages in terms of obstacle avoidance, in terms of changing the direction of arrival, and so on. And all of this work has had both simulations and electromagnetics, the stuff we do at SUNY Poly, as well as experimental validation, the stuff we do through our collaborations right now at Northeastern University. We've also got quite a few publications out of this, some high-impact journals, high-impact conferences, and the way we usually like to do these things is we plan our work in the spring, we do our work in the summer, we analyze the research and the experiments in the fall, and we try to publish in the winter. So that's kind of our battle rhythm. And right now we're in the planning stages, so we have a few things planned out. Mostly we've taken care of wavefront. Now we're going to jump the gun, switch to waveforms, which is modulations and dealing with frequency selective software, and then combine the two together. And that's where our future programs for development comes in. Right now we're in the planning stages of a master's in electrical engineering. It's still in planning stages. We had quite a lot of students in our undergraduate class who expressed interest in wanting to learn more. We're building towards this, mostly in communications and signal processing, but there's also interest in power systems. We have the 6G development going on with that test bed. It's going to be one of a kind. With that, we hope to be able to secure more collaborations. Right now, we are working with folks at Florida International University, University at Albany, Northeastern University, and so on. And to be able to drive these kinds of research thrusts, We, of course, are also trying to hire new faculty. So the goal is to get towards 6 full-time faculty with N number of adjuncts who can fulfill our needs, who like us. We'd love to work with them as well. I also wanted to highlight a few of the students. Of course, you might be familiar with a few of these faces. Our students do pretty well, not just at AFRL, but also nationally. We have students all over, and they've gone on both in industry as well as graduate work. And it's not just our students. In fact, our interns are also doing pretty well. Just wanted to highlight some of our more recent interns. We also have interns in other departments and in other industries. And if you're interested in any of these things, you want to talk to us about anything more, this is us. 4 of us get the job done. Hopefully there'll be a couple more in the coming years. And with that, thank you so much for your time. And now I'll hand it over back to Dr. Carpenter.
Thank you. All right, so I'm going to do my best to pretend to be an expert in cybersecurity. Apologies, Professor Hisham Khalidi wasn't able to meet with us today, but he's our main contact for this program, and he's currently the chair for this department as well. So within the cybersecurity program, we have both the bachelor's degrees and the master's degrees available, and all kinds of activities within the cybersecurity club. This is one of our more active clubs on campus. They like to invite speakers to come in and speak, and they have all kinds of projects and attend various hackathons across New York as well as across the nation. We're setting up in the future with this $3 million WDI grant, a cyber range. So we're currently planning that, so we don't have that in place yet, but we're actively talking with the folks here and the folks within the ACE program to see what works for you. And then we're also talking with the folks at RIT and other places to find out what makes a good cyber range so that we can best utilize the funds that we have at our hands. And then we have, through the faculty, and Professor Khalidi in particular, the Advanced Cybersecurity Research Lab. And just a little bit about his work, and again, I know nothing about this, but it's really cool work, and what I really appreciate is he's setting up essentially various test beds. And so he's got a 5G test bed that's on campus, kind of a modest in size, and he's actually working through a CRADA currently with the Air Force Lab, and I'm told it's nearly done, but it's been nearly done for a bit, so hopefully that'll come soon, which I guess that will allow us to expand that test bed quite significantly within the SUNY Poly facilities. And then, of course, if there's 5G, then there's going to be 6G and XG, and he's got all these programs that are building off of themselves. And the federated test bed is quite interesting because it's not just localized. He's got collaborators in many different regions, and in particular, folks at Virginia Tech, one of the universities in Florida, and I forget which one, and then University of Arizona, where he has strong partnerships with faculty there. And they're going to be setting up this federated XG test bed in the coming future. And then within the labs on campus, he's working on establishing a smart cyber physical water test bed. This, I think, is in collaboration with one of those groups. And then an AI machine learning based platform for a smart vehicle-to-vehicle test bed to ensure secure communications between vehicles. So a lot going on, and there's a sampling of the publications from both himself as well as Mahmoud Bader and Zahid Akhtar, two of the other research active faculty members. And right, there's the list of the faculty on the left. So Hisham, John Marsh. John Marsh has been a long-time faculty member at SUNY Poly, been terrific for our program, and he's retiring after this year. So we're sad to see him go, but he's been fantastic in setting up the program and then getting it up and really positioning it incredibly well for the success that we're currently having as well as where we're positioned for the future. And then Professor Zahid Akhtar and Mahmoud Bader, they're both assistant professors. Mahmoud came to us just last fall, and Zahid has been with us about a year and a half. And in order to mount both the undergraduate programs and the graduate programs, we need a whole stable of adjunct professors. And you may know some of the names here. They come from the local area, and they're just fantastic to work with. So I'm really very happy to work with such great faculty, the adjunct faculty, because they bring that practical industry experience or government lab experience, and what they're able to do with our curriculum just really sets it up for the students to appreciate the practical side of what they're learning within the programs. And that outside experience helps to reinforce that. Some areas where we're growing in the future, working on setting up a Center for Academic Excellence in Cybersecurity through the National Security Agency. This certification is something that we're going to begin to step through. PhDs, as I mentioned earlier, not in our short-term plan, but certainly in our long-term plan, and long-term meaning 5-10 years would be my guess. It could go faster, but it just needs much more support from SUNY to help that go. And to become a regional cyber range training hub, and this $3 million WDI grant is going to help us fulfill that goal. We're currently hiring faculty within the cybersecurity program, and expansion towards 4 is where we're going in the future, but going beyond that is I've got asked into our officer in charge to grow by 2 or 3 in each of the programs that you're talking to today. Because we definitely need that to continue to grow the undergraduate program as well as the master programs. And again, always looking for adjuncts. So if folks here are interested in teaching, again, please reach out. And just like with ECE, our graduates have done really well. And I won't read through this whole list, but our students, both undergraduate and graduate, have been hired both locally and nationally. And so again, lots of opportunities for our students, and really appreciate the opportunities that you all provide here, and looking to continue to grow those collaborations. So with that, I'm going to pass it off to Professor Rial.
Okay. Well, hello everyone. I'm Dr. Michael Riali. I am the chair of the Computer Science Department, as well as the Master's Coordinator for the Computer Science program. So just want to run through a few details of what we have here. So as Dr. Carpenter has already mentioned, we have a bachelor's in computer science, which focuses on kind of the balance between software development as well as the underlying mathematical and ideas and concepts of what is computable, things along those lines. We have an information systems BS, which focuses more on how computing is applied to the business sector, more things related to system design. So it's kind of a different pivot point for a lot of our undergrads. Our applied computing degree is more of a special case for people who have, say, an associate's in a potentially unrelated field, like the example I use a lot is, say, they have a music degree, for instance, but they want to pivot into a computing platform. So most of the heavy hitters are the first two. We also have a master's degree that's usually a 2-year program. In terms of the way it's organized, it focuses around 4 different silos in terms of different topics and areas of interest: software engineering, systems and architecture, algorithms, artificial intelligence and modeling. And we try to keep it fresh by incorporating different kinds of special topics courses that are relevant to whatever's happening at the moment. So for example, I'm teaching a image translation and generation course this coming fall, which is related to all this sort of text-to-speech, or not text-to-speech, excuse me, text-to-image kind of generation stuff, and all of the sort of newer models that are sort of cutting edge at this point. And then we also, as Dr. Carpenter had alluded to, we have an accelerated program where people can complete a bachelor's and a master's in 5 years, basically by taking 4 graduate courses as an undergrad, and that basically chops off approximately a year off the program. So a lot of our best students enter this program, and it's a really productive program to help people, get more advanced in their field. So, in terms of our faculty, I'm not going to list the entire list, but we have 12 full-time faculty. A lot of them are, have received awards for either teaching or service. We have approximately, it depends on the semester, but usually we hover somewhere around 4 adjuncts. And as Dr. Carpenter had mentioned, those adjuncts are really a vital part of our faculty. They provide a lot of the, not only the supports for the cores, but also special topics. And I'll reiterate what's been said a couple times already, that if you are interested in adjuncting for us, again, we always appreciate the expertise that you guys bring to the table, the real world experience. there's a lot of different options on that front. And a lot of our faculty are research active in various ways. I'll show a slide with a couple of more details on some of the projects we have, but it varies from things focused more on machine learning, deep learning, things related to that. We have people working on quantum computing, we have people working on blockchain, we have people working on different flavors of algorithm development. So there's a lot of different kinds of projects, whether they're internal to us or whether they're expanding out to other entities, including the AFRL. Some of these are things that I've worked on, so my expertise, amongst other things, has to do with 3D facial expression recognition and how that ties into deep learning and machine learning. So a lot of the projects we've tied to have done that, and we've had a couple of publications related to that. One of my colleagues has concentrated on algorithm development with some undergrads and graduate students that he put together. He developed this algorithm called sheep bubbling, which, you know, it's kind of an interesting little algorithm that came together. We do some work with image analysis having to do with retina and medical images, and a project that I've worked on several times with the AFRL has to do with generative adversarial networks and transforming different pieces of satellite images. So we have several faculty who have worked with the AFRL at various points, and we're always encouraging our newer faculty to integrate there, and there's always different opportunities in that respect. So in terms of future expansion, so right now we are looking for an IS tenure track to help with a colleague of ours who is retiring, as well as a CS lecturer. And again, we're also looking for adjuncts to help fill out our, different course roster. In terms of how we're using our part of the WDI grant, we are upgrading our computer labs. We have 2 smaller labs, and we're going to be refitting a larger room into a larger computer lab. And the main idea with this is to try to get equipment that allows us to do in-class kinds of projects that allow you to leverage things like GPU acceleration, whether it's for deep learning, machine learning, computer graphics, other kinds of heavy lifting computation. So it's going to dramatically increase our capacities in terms of what we can do both in the classroom as well as things we can assign to students once, either offline or for capstones or graduate projects or what have you. And related to that, and this also ties into any sort of potential research collaboration, we are getting 2 GPU servers, which are basically, batch job kind of centralized setups. And we're hoping to get that set up so to help our faculty with different research projects, as well as potentially for master's projects and theses as well. So we're going to definitely be upgrading our capacities in the near future, and that opens up a lot of doors for us in terms of computational power locally. And then in terms of our students, we have a very active CS club. The programming competitions was put on hold for a little bit because of COVID, but they're starting to bring that back. They bring speakers in, they do all sorts of neat little projects, and they're trying to expand those capacities as well. We always welcome if there's people who are interested in potentially giving a talk to them or any sort of thing like that, please reach out to me. I'd be more than happy to discuss that. And our graduates, like a lot of the other degrees we have, they're basically all over, both locally and just globally. So people working at Microsoft, NASA, IBM, a lot of people working for the various contracting companies around here. So a lot of exciting stuff in terms of what we're doing and what we're trying to accomplish. So that being said, does anyone have any questions? So I went through that a little bit fast, but amazing. So, all right, well, thanks very much. I believe I'm going to pass it off to Dr. Yulian. So.
Hello, everybody. I'm Yulian Gerasoiu. I'm an associate professor in electrical and computer engineering technology, and I'm also the coordinator of the 2 programs. So I'm going to describe a little bit what we do in electrical and computer engineering programs. So we have a couple of concentrations. One concentration is in microprocessors, where the students would find out about the architecture of the microprocessor, programming microprocessors, and mainly interfacing microprocessors with the external hardware. Then we have another concentration in control systems, where the students get the basics of the control systems for all kinds of systems. And then communications, that is focused more on optical communications, fiber optics. And finally, the minor and we hope a concentration in the near future in nanotechnology and semiconductor manufacturing that covers the processes and the equipment that is used in semiconductor manufacturing, as well as applications of the semiconductors and the use of these equipments for the fabrication of material and devices. We are also planning to expand our range of preoccupations with master in science in engineering technology, and we need for that more support from people that would like to teach and be adjuncts at SUNY Poly. So our two programs are supported by 4 full-time faculty now, myself, the program coordinator, Dr. Mohammed Abdallah, Dr. Bong Muk Lee, he's an expert in silicon carbide and devices, power devices that are built on silicon carbide and gallium nitride, Dr. Gunyaz Ablai, and Michael Mazzati is our lecturer, and as well Mr. Micheline Abraham. He's a lecturer and the director of the NIATEC. Last fall, we had about 117 students registered, and we hope to grow back to the level that we had before COVID-19, which is around 150, 160 students. Currently, we are adding 2 new full-time faculty positions, and we are interviewing for that. So next, I would like to describe to you a little bit what our expertise is and what our research preoccupations are. Myself, my expertise is in synthesis and the fabrication of semiconductor devices, synthesis of nitride semiconductors, gallium nitride, indium gallium nitride, and optoelectronic devices such as LEDs, solar cells, and as well as high electron mobility transistors. I have a good experience or a long time experience in using MBE systems, molecular beam epitaxy systems, and metal-organic chemical vapor deposition epitaxy systems. Currently, on our site here, we do not have equipment for semiconductor synthesis. We look forward to acquire molecular beam epitaxy systems and install it. We are working, we are still doing research out of the many hundreds of wafers that we generated in our previous time in the industry, in the research community. And we are also working with the CNSE, College of Nanoscale Science and Engineering in Albany, where we can still generate semiconductor material and fabricate devices with the help of the equipment that is installed over there. My colleague, Dr. Bong Muk Lee, he is, as I mentioned, he's an expert in wide bandgap semiconductors, silicon carbide, and gallium nitride. His expertise includes the fabrication of sensors and sensor arrays that expands now to the fabrication of integrated circuits based on silicon carbide. And that would require more work on the design of the integrated circuits as well as the processes that would produce such integrated circuits. A few words about our prior graduates. You can see here we have students that were hired all across New York State. One of them that graduated not too long ago, Andrew Brownell, works somewhere here. I know that 2 months ago I visited his lab and he was very happy with what he's doing here, and he actually stated that he was inspired by the work he was doing here to return to school and finish his master's. So I think that's a successful interaction with the industry. And I'll hand now the
Good afternoon. I'm Bill Durgan, mechanical engineer, aerospace engineer, presently at SUNY Poly, and tell you a little bit about our mechanical engineering program there. My own background is, as I mentioned, in mechanical engineering and aerospace engineering. Been at this for a long time. I was at Worcester Polytechnic Institute for about 35 years, Cal Poly for about 5 years, and now at SUNY Poly, where I've been a little bit more than 10 years now. Tell you a little bit about what we do at SUNY Poly. We have a core curriculum. We have a bachelor's degree right now in undergraduate education. We will graduate about 30 bachelor's candidates this year. We've been in existence now for, well, 6 years since our first graduating class. So we've been formed now for 10 years. Our core curriculum focuses on applied mechanics, fluid mechanics, heat transfer, thermodynamics, and material science. We have some focus areas. Many of you may be familiar with the CGAM facility in Donovan Hall, which contains a suite of very, very advanced manufacturing equipment and measuring equipment. We have great interest in robotics, interest in aerospace engineering, computational fluid dynamics, and material science, and I'll tell you just a little bit more about those as we go along. Let me get the right button here. Some of my personal interests have to do with electric aircraft. I serve on the AIAA, IEEE Electric Aircraft Committee. I've been involved in the design of electric aircraft, both fixed wing and rotary wing aircraft. I teach a course in unmanned air vehicles, courses in turbulence. That's my own real love, is understanding turbulent flow. One of the things that I've done in that connection is to study at great length the sound propagation, high-frequency sound propagation, ultrasound, if you will, propagation through turbulent flows, with an effort towards understanding the details of the structures in turbulent flows, and in flow measurement, especially measurement of fluid flow non-invasively, especially using sound as the probing medium. Yu Zhao, who many of you may know as Joe, his specialty is in robotic systems, especially swarms of robotics and the collaborative behavior of swarms. He's interested in connection with that, machine learning, and in robotic manufacturing, where he's especially done quite a bit of work in the fabrication of composite materials using robotics to lay down composite materials. He works in the area of robotic navigation, UAV navigation, signal processing, image processing, and sensing and actuation of robots. I don't know if I got a slide on this a little bit, but we have very active undergraduate student group in the BattleBots competitions, and we have been for years involved in the first robotics competitions. So wonderful ways to promote the importance of STEM education, especially to students in the formative years, especially high school years. Arthi, Dr. Sekaran, our newest faculty member, her specialty is primarily in heat and mass transfer and the associated fluid mechanics. She's especially interested in the transport and the behavior of layers at the surface of the ocean and how atmospheric gases are absorbed by the ocean and how the ocean affects the structure of the first layers of the atmosphere. She's looked a lot at flow instabilities in two-phase flows and in the area of computational fluid dynamics. She's quite expert in that area. And she's been with us about 2 years now and is one of our real up-and-comers. Xiong Tang has a lot of interest, mostly in the area of the prediction of the properties of materials. He's able to apply artificial intelligence to assemblies of molecules in a matrix with regard to the likely mechanical and electrical properties of those materials if they could be formed. And he's done a lot of work there, especially with undergraduate students, and resulted in a number of collaborative publications with our undergraduate project students. Just a couple of words about capstone design projects. And by the way, I come at this from a long history. As I mentioned, I spent a lot of years at WPI, which is renowned for its project-based educational programs. It's learn by doing attitude. And I've actually run programs in association with the Navy Underwater Systems Center, Draper Labs, and now 4 of the NASA centers where we put students into those organizations for a couple of months, basically, and in association with their senior project work. And we've been working very hard in mechanical engineering. I think this year all of our projects, and we ran 10 undergraduate projects this year for about 30 students, they were all in association with some corporation or industry or NASA center or other entity to give them that real world experience. We have a number of projects going on. One is to remove materials, to pick and place basically materials. Another is to clean with one of the local companies, to clean slate that's manufactured by that company without actually hand scrubbing that material, to automate the cleaning process. And of course, the photograph up there of one of the BattleBots robots. I think they're about to head off to their first competition soon. The students love these contests, and they involve a tremendous amount of mechanical, electrical, and computer and programming efforts. So it's really an integrated efforts as far as the learning experience of the students. And just a photograph down there of some of our students operating a robot. There are 4 of us on the faculty. We have 2 open slots right now. I've told you a little bit about myself. Xiong Tang, who comes to us from MIT, he's really quite impressive with regard to his material science background. Zhou Zhao, who's really tremendous with regard to robotics and the behavior of robots and the application of robots to manufacturing processes. And Arthi Sekaran, who's expert, is in the mass transfer, heat transfer area. And one of the things that may be of interest to some of you folks is that she's really interested in thermal properties, thermal behavior, and control of nanotechnology circuits, removal of heat, thermal control of very, very small things. So that's the faculty we have right now. We have a plan in place to grow tremendously in size by a factor of about 3. And we have recently put forth a proposal to form a master's program, which hopefully will come through in about a year. And right after that, we plan to go forward with a PhD program as well. So that's the story for mechanical engineering. And Mike, back to you.
Thanks, Bill. All right, so I need to put on another hat now for Mechanical Engineering Technologies. As I said, Professor Joyce Shen, she's our program coordinator. She wasn't able to be with us today, but I can provide you with a nice summary of the work that's going on in that program. So it's, again, a bachelor's degree in Mechanical Engineering Tech, and not sure if he mentioned it yet, but all of our engineering and engineering tech programs, they're all 4-year degrees, they're all ABET accredited. So I just want to make sure we highlighted that as we go along. Our last review was in the fall, with the site review was in fall 2020, and we were one of the first ones to do a remote ABET site review because of the pandemic, and that was really very interesting to walk through, but we got through it. In MET, we offer 4 emphasis areas: mechanical design, computer-aided engineering graphics, thermal sciences, and energy systems. We've got a lot of dedicated labs, and if you haven't been to our campus, please reach out. I'd love to have you over. We'd give you tours. The CGAM facility really is quite nice, and we're going to be expanding quite a lot in that area over the next year with respect to advanced manufacturing and robotics, as well as semiconductor processing. But we've got a full CNC machine shop. We've got a 5-axis mill. We've got additive manufacturing, a whole mess of 3D printers that can print the simple plastics as well as composite materials. We've got a nano lab with an AFM, a scanning electron microscope, and we have recently a donation from Corning of an X-ray tomography tool, so we can do non-destructive imaging of a variety of samples. We've got the measurement labs, and then you can read the rest. These are a lot of the educational labs that we have as well. We also have a wind tunnel on campus as well, so if you're needing to test anything with respect to flow over various structures, the wind tunnel is available too. We've got 4 professors, and we do have an ongoing search as well. That seems to be our common theme, and as I said, we're actively searching, but also asking for even more faculty in the coming years. And we currently have about 9 adjunct faculty members that help us offer the academic program. And MET, like mechanical engineering, is one of our larger enrolled programs. We've got 144 students. Computer science, hands down, takes the cake there because they have the largest enrollments. But we do have some healthy bodies of students. Capstone projects, these are really cool ones. Between the SAE Baja Club, they've got to build a vehicle every year. And this year, as part of the club, as well as the capstone, they have to institute all-wheel drive. So the students have to design it, build it, and integrate it into the vehicle. And they enter competitions both locally as well as across the nation. And they're currently trying to get themselves to Oregon for the competition this year. And I think they're pretty close to meeting their funding goal. But then non-pneumatic tires, a multi-tool, a motocross sproder, and we have a lot of other activities related to humanitarian engineering projects where they work on teams with engineers, social scientists, as well as health scientists students for projects that are relevant for the community. And those are really cool, and if you're interested in that, I can share you some neat stories about Braille blocks. And we 3D print Braille blocks for CAB-V, and we're looking to take that to scale by acquiring a injection molding tool so that we can make these devices and others to scale levels. Research highlights, Dan Jones, he does a lot with assistive technologies and electroencephalography, if I got that even close to being right. He's one of the faculty members that works with our health science and social science related faculty and analyzes reams of data with how people react to various environments. So the data is acquired by the team, and then Dan works through crunching the numbers to try to find the right patterns. Jay Upadhyaya does some nice work with microfluidic sensors, CFD, additive manufacturing, and some optical applications. Kazi Imran, he's our newest one. He does a lot of work with composites. And then Joyce Shen, she does some nice work with sensors, wireless sensing, wearable sensors, and flexible electrodes. And within our facilities, we also have a 3D printer that'll print biocompatible materials as well. With the common theme, our students, even in this program as well, end up all over the place. And this is just a snapshot of some of our recent graduates and where they've gone. And you can see both small companies, big companies, and companies across the state as well as the nation. So that's our presentation for today. There's a lot of information, but again, we have, I think, lots of opportunities where we're positioned for growth. We've acquired a lot of funding. I'm pretty certain we're going to get a lot more funding in the near future, as well as funding for more faculty. And our programs, both on the academic side in terms of what we offer, undergraduate and graduate programs, that's just going to continue to grow. And we're really looking for collaborations of all kinds, whether it's research, teaching, just mentoring students through the capstone projects, et cetera. So happy to be here today, and glad to provide this little snapshot, and we'll take any questions that you might have.
So really quick, I think because you all called out that you'd love to have more adjunct professors, and so adjunct professors are something that you can do on your own time after work hours in conjunction with your current work as an AFRL employee's perspective. And so I'd like you to talk a little bit more about those opportunities, how you find them, and what are your biggest needs that, like, all right, if someone with AI experience walked up to you today, do they have a job? And so what are you looking for whenever you do that, so our folks have something that they can really latch on to of how to pursue that more?
Yeah, so I think we have the adjunct ads all posted, and they're kind of always up. But I can defer to the folks here today if there's any outstanding needs for fall. But yeah, if you see anything that aligns with your interests, I would say reach out. We may not have an opening this coming fall, but we'll work with you to find where you can help us, whether it's that fall semester or an upcoming or the spring semester. Because we do have some turnover and we do have some holes. And I think every one of the programs would like to probably offer a little bit more in terms of the coursework, maybe the electives, and that might be some opportunities where it'll align with your interests and aligns with the program. But if you guys know of any real specific needs for fall, come up.
So, just from the ECE department, Dr. Tim Bush is retiring, and one of the things that he really used to teach and he has great expertise in is our senior capstone design. Our senior capstone design is a little bit different from other places in that we have 2 semesters, a lot of emphasis is placed on it. And I do believe that right now the plan is to find an adjunct. I forget the name of the person who's expressed interest in being a part of that. So I believe there's definitely that spot open. If you're interested, please do let me know.
Could be a really good opportunity for someone that's looking to help mentor some programs and capstones that haven't been in conjunction with our current programming.
I'll only say briefly that we have we pretty much can use almost anything, but at the same time, we always are looking for people to do, say, special topics for advanced electives, whether it's for undergrad or grad. So if you have some particular subject area or particular topic of interest, definitely reach out to us. I would say too that the ads are always posted, but it always helps to ping either whoever's the chair of the department or Mike, Dr. Carpenter, to go from there, basically. So. Yep.
And if there's interest in teaching master's courses beyond what we currently have, please come up. I'll just keep talking while you're coming. So again, the systems engineering, that's an area we'd love to mount, but we need more people. And then the future master's degrees, they'll be coming, but then we obviously have the master's in computer science and cyber. Please go ahead.
Hi, Dr. Rialli. It's been a while. So I was at SUNY Poly just a couple years ago. I graduated in May of 2020. Finished in both the ECE program and the computer science program. It was a fun time. Had a great time, learned a lot. When it comes to adjuncting, are you guys open to and considering the possibility of cross-listed electives? For instance, I know that in the computer science department we have CS 330, operating systems and networking. Networking wasn't a huge component of that class, but it was there nonetheless. And there's a upper division computer networks class in the ECE department as well. I think that there's probably room for some kind of guest lecture for, get the software guys a little more hardware and get the hardware guys a little more software. Another one that comes to mind is ECE 352 and CS 441, which Dr. Confer was teaching for a while, which was computer systems architecture, and on the ECE side was computer architecture. Both, I actually took the ECE one. I didn't take the computer science one, but I had friends who took that, and they were both very similar in material, but computer architecture was one of my favorites, and just putting it out there, I'd be glad to, given the opportunity to maybe adjunct, and we can talk more offline, of course, but it seems like there's a lot of overlap in some of these curriculums, and I'm just wondering if you guys have thought about that or talked about it when it comes to cross-listing courses.
It's definitely come up, basically. It is something that we would definitely be, at least I can speak for CS, would be interested in exploring. So, yeah.
Okay. Cool.
And kudos and A+ for remembering all of the course numbers and names. So
Oh, man. I'd
have to go look them up.
No. Man, I spent hours scheduling throughout all of
With a
them.
dual major, no doubt.
So by the way, Dr. Riali said that he'd be really interested in cross-listed for computer science, and I wanted to mention that EC would be interested too. For computer architecture, in fact, Dr. Bush is leaving, so if you're interested in that adjunct, I think that would be a great spot to come in. We're working on filling that spot right now, excuse me. We've also actually thought a little bit about a cross-listed course throughout the engineering department, believe it or not, which would actually cover the recent advent of ChatGPT, and that, how do we basically deal with ChatGPT coming into the picture, because I already told all the students in my SDR class, go ahead and utilize ChatGPT as much as you want. I think my class requires thinking, not memorization. So it'll get you there, but then you still need to build up. And it's something that Dr. Carpenter and I have been discussing a little bit, how to create this kind of broad course for ChatGPT. So definitely cross-listing is a very good idea. And for computer architecture, love to talk to you later on. Thank you.
So I think I speak for all of us that knew him that Dr. Bush is not replaceable, so good luck with that. We're going to miss him greatly as he retires for the 3rd, 4th, 20th time from SUNY Poly, so we'll certainly miss seeing him there on campus. So can you talk a little bit about what qualifications for adjunct professors look like, and what do you look for, and what support do folks have if they step up and say that they are interested in lecturing or adjuncting, but maybe have never taught before? So what support do they have from you guys to learn that on that end of the spectrum?
Yep. So the rule of thumb is you need a degree at least one higher than what you're teaching. So if you're going to teach an undergrad course, you should have a master's degree in that discipline. We do make some exceptions for some of the lab courses where there's a boatload of experience that folks bring to the table. So there is a little bit of wiggle room with respect to that, but that's usually the rule of thumb. And then in terms of support, we're looking to improve that onboarding process, but usually what happens is the faculty get connected with the department chair and or people that have taught that same course in the past. Lecture materials are exchanged. They don't have to use the same lecture notes, but at least it gives them a starting point. But they do need to, they'll be well versed in, for the ABET accredited courses or programs, make sure they hit all of the learning outcomes that are needed to be touched on. So there's it's more of an informal onboarding process. We don't just let you sink or swim because that just hurts the students, and it could be a painful experience. So, and if people want to come on slow, like giving guest lectures, we'd love to have that too, because again, a lot of the faculty do that, and it gives the students that outside perspective. But a couple of guest lectures, or even just teaching a module, that's also another opportunity to dip your feet in a little bit, and then if you like it, we can set you up with a full course. Yes.
You mentioned a couple of areas about a PhD program. What do we do as a community to help that occur? Because it's something that I've been pushing for 4 years or longer.
Can you ask that question?
Sure, I can. You mentioned hopefully bringing a couple of PhD programs here. I don't remember what department it was, or was it ECE or computer science. That's something that I've been pushing for 40 plus years in this area. We're going to be a high-tech area, but we don't grade a PhD. How can you possibly continue to say you're a high-tech area without that? So is there anything we can do as a community, the Air Force, the industry at large, to help make that happen?
Yep. Yeah, I agree. And in order for us to hit that mark of a premier public poly, absolutely need the full gamut of the master's degrees and the PhD degrees. So I agree 100%. And in terms of what you all can do, just continue to be supportive. It's kind of a weak thing to say, but SUNY needs to know that this campus is a critical asset to the community and beyond, and continue to voice that. I think from what we've demonstrated today, I'd like to think we've shown we have a lot of neat projects. We work with a lot of companies. Our students populate companies both in the region as well as across the state and nation. So we're doing a good job, and we just need more support to grow. So continued voice of that support to SUNY and to if you're connected with any politicians, please do that as well. And be willing to help serve as collaborators for thesis projects. I think that's always that's a great connection for the students, both for the master's theses as well as the PhDs, and joint advisement through even a courtesy appointment is possible. So that's where I'll start. But I guess Bill, you've got a couple points you want to make?
Yeah, you just hit on one of my hopes and notions here that we really need to achieve. Let me just say that the practicality is that SUNY and SED, the State Education Division, required that you be prepared to offer a program before they will approve it. And so this is a key step for a PhD, for example. You have to have enough faculty, have to have enough students, and you have to have enough facilities, and you have to have enough funding. And that's the hurdle that you need to get over in order to get a PhD program started. I have no difficulty with the faculty, with the students. I think we need a little more robust suite of facilities, but the big thing is going to be sponsored research, because with a PhD program, you all know that you don't go get a PhD degree in a STEM area if you're not on a teaching assistant or a research assistantship. And so the key thing is for us to generate enough research programs to be able to support the students. And that's the real key to establishing a PhD program. I'll give you one example of a program in robotics that started at year 0. 10 years later, they offered their first PhD in robotics because it was such a hot area and they got so much corporate support for that program. And so, it's not impossible to do quickly, but it does require a strong commitment by a lot of people to make it happen.
Oh boy, I am tall. Okay. My name is Cody Kearse. I'm a AFRL researcher here at the lab. My focus is in artificial intelligence. Thank you, Karen, for putting this on. A couple of things stood out to me. Electroencephalography is the correct word. I have a background in the social sciences. I have experiences doing EEGs on personnel, but I also work in AI. So I'd be very interested in having a conversation about that and taking a look at the actual signal processing and see if you can point the neural network at it and see if you can do anything cool. Second, in the areas that I work in, there's a big interest in leveraging some of the newer technologies that are out. The generators as far as text to picture, and then of course GTP3, GTP4, and I'm really thrilled to see that the universities are looking into that and getting hands-on experience for the students. So I think there's also potential research collaborations that are available there with the groups that I'm in, because we're looking into how can we use that, and we're also looking into how do we use that with data that's already readily available from our standpoint, but also something you could look at too. So I think there's some good connections that can be had in the AI world.
Terrific. Thank you.
No problem.
Glad to know I pronounced that word right. That was a tongue twister for sure. All right. Yeah, please.
Hi, Jeremy Chapman. I just had a question that kind of follows on to the support for adjunct professors. If you adjunct a class, do you get support from a teaching assistant and or graders or anything like that, or is it kind of course dependent, I'm guessing? But
It depends. If we end up having TAs and graders for courses that have a lot of students. So if it's like 30 above, which can happen with some of the larger programs, we tend to actively find graders for folks who are teaching that, because that's a lot.
okay.
But if it's a course section of, say, 20 or so, usually we don't, but you can always ask.
All right. Thank you.
Quick shot back at you, but in what field would you be interested in adjuncting, if you don't mind me asking that?
Probably in the mechanical field under aerospace. My background's in mechanical and aerospace engineering, primarily aerospace.
Gotcha. So I don't know, maybe Dr. Durgan can speak more to that, but I do believe that your students, assistants, need to be graduate students, if I'm not wrong. If not, that's not the case, then that's perfectly valid, because something that we are trying to be careful in ECE is if we get our graduate students from, let's say, computer science, they're very good when we're talking about, let's say, computer architecture, because as, I forget your name.
I didn't say my name. It's Dylan.
Dylan, as Dylan mentioned, hi Dylan, as Dylan mentioned, there is a great overlap there. But then if you try to utilize computer science more towards hardware or more towards power systems and things like that, then you need to help the grader first, and then they can take over. So so they'll help you in both cases. In one case, you might need to put a little bit of effort with them up front before they can do that.
Okay, that makes sense.
And I'll just add that undergraduate graders are possible. They just need to be above the course that they're grading. So they can't grade the same level of say, a 300 level course. If they're going to work there, they need to be, say, a senior student.
Right, makes sense.
Yep. All right.
All right. I know that we're well past 1 o'clock, so I am going to say that we can end the recording now. I know Dr. Carpenter was planning on staying for a little bit for any follow-up questions. We really appreciate everyone coming out and asking lots of good questions and hearing what these folks have to say. We'll continue to stay in close relationship with them, so definitely listen for more, but don't hesitate to be proactive in opportunities that you see out there. And with that, have a good rest of your day.
Great. Thank you, everyone.